Our next speaker is Alison Trude. Alison received a Bachelor of Science in Psychology from the University of Pittsburgh in 2008. And from there she joined the Psychology department at the University of Illinois here, where she received her Master's in Cognitive Psychology in 2010. And currently in her 5th year of graduate students, and she is a NSF fellow, and her research interest includes speech perception and the role of sleep in memory for new words and voices. Alison Trude.
Is there a way to get this so that it's not showing the...
Yes. Let's... there it is.
So today I'm going to be talking about what listeners are able to learn about different speakers' voices and how they're storing that type of information in memory as they're exposed to new speakers. So here we have a picture of two people that hopefully everyone recognizes, and they have very different dialects of English, as we all know. Yet we see them here having this very nice casual conversation. They're able to understand each other relatively easily, we would suspect. And so this highlights something really important about understanding speech, which is that everybody's voice is different. So some people have a higher pitched voice or a lower pitched voice. People talk at different rates. People's language background may cause them to have different accents or different dialects. No two people's voices are exactly the same. And if we think about it, that should make understanding speech really difficult. We're never hearing the same thing twice when we hear speech at a very fine-grained acoustic level. However, this is something that we as listeners of speech don't really think about very often, because usually we can understand other people's speech very quickly and with very little conscious effort. This is something that's very easy most of the time for listeners to do. But relatively little is known about how listeners are able to adapt and adjust to different speakers, or what kind of information they're storing in memory or how they're accessing it. And those are the sorts of things that I'm interested in my research, and so I'll tell you a little bit about the work that I've been doing today in this area. So the methodology that I use to study speech perception is eye tracking, and I'll show you a picture a little bit of what our lab looks like. But the thing to know is that speech unfolds over time. So for example, if you hear somebody say the word tack, you don't hear the whole word all at once. First you hear the t, then you hear the a, and then you hear the k. And so eye tracking is a nice way to look at speech processing because it's very temporally sensitive. We can get millisecond level accuracy of where the eyes are looking. And the assumption that we're making here is that listeners are more likely to look at images in a display that correspond to what they're hearing, so likely interpretations of the speech that they're hearing as they're viewing these displays. And so we can line up a participant's eye movements where they're looking with the speech stimulus, and so we can see how they're interpreting what they're hearing as more and more of the word gets presented to them. And so here's an example of what our lab setup looks like. Here we have our participant. He's got his chin on a little chin rest to keep his head still. This is my advisor, Sarah Brown-Schmidt, and this little thing that she is adjusting here is the eye tracker. It's just like a camera. So again, this is a non-invasive method. It's very comfortable for the participants. The participant is looking at some images on a screen here, and then we have some speakers, and they're hearing audio coming through the speakers. And I'm over here controlling the eye tracker, and so you can see here's the participant's face and eye. And so just to sort of give you an example of the types of displays we use and how I get the graphs that I'll be showing you a little bit later in the talk, here's an example. So normally our participants see a display with 4 pictures on it. They don't see these colorful circles. This is just for me, helping me to explain this. And so we, first of all, always have a target image. So this is the image that they're eventually going to hear somebody name. So they're going to hear somebody say tack in this case. We also have a competitor image. This is a word that kind of starts out sounding the same, but then later on diverges from the target word. So here, for example, we have a tag. So at first, when you're listening to speech, maybe you've gotten to the point where you hear the person just say ta, and you haven't heard that last consonant yet. You don't know if it's going to be tack or tag. Then you hear the k, and obviously you can figure out which picture it's going to be. And then we have some unrelated pictures on the screen. So what we can do is we have a number of trials that our participants do, and on each trial we can get a record of where they were looking as they heard the speech. So for example, maybe on trial number 1, they started looking at the target right away and then just kept looking at it. Maybe on trial 3 here, they were tricked by our competitor, then they heard the k sound and switched and started looking at the target, and so on. And what we can do then is we can average our data from all of these trials, and we can make these nice looking graphs like this. On the x-axis here, I'm plotting time, and this is relative to the onset of that word tack. So this is more and more of the word being heard. And the y-axis is some measure of how much the participants are looking at each of the pictures on the screen, so proportion. And what we normally see when we do these types of experiments is that as the participant hears more and more of the word, they're building up evidence as to what the correct image is to look at, and by the end of the trial, they're looking mostly at the target and not so much at these other pictures on the screen. So using this methodology, I wanted to know whether listeners could learn details about different talkers' speech, specifically their accents, and rapidly access those information as they're listening to speech in a multi-talker setting, so 2 people with different accents. And so here are the accents we use. I do have some audio, but it's really quiet, so hopefully you guys will be able to hear it. So we had a male talker with an accent. This is a real accent of American English, where his a vowel was pronounced as a, but only before g. So a word like tag, he would say as tag, but a word like tack, he would say normally as tack. So let's see if I can get these to play.
Hey.
It's pretty quiet.
Tack.
Okay. So, but tag and tack, you can hear that they have clearly different vowels for this speaker. Our second speaker was a female talker. She was from the Chicago area, and crucially, her accent doesn't have this feature. So for her, like most of the rest of us probably, tack and tag have the same a vowel in them. So what we do is first we train our participants on the images that they're later going to see at test. This is just so they know which pictures go with which words. Then they have a period of auditory exposure where they listen to the talkers reading a dialogue that contains all the important words that they're later going to hear at test. Then finally, we do our little eye tracking task like I just described. And crucially, the 2 talkers alternate randomly, so the participants never know who's going to speak on the next trial. And so here's an example display. This is the same thing that I just showed you earlier. So the participants see these pictures pop up on the screen, and then they hear either the male or the female speaker say something like, click on tack. And so if we're listening to the female speaker who doesn't have this accent, tack and tag have the same vowel. So when you're at the point in the word where you've heard her say tack and you haven't heard that last consonant, usually what happens is participants look about equally at these 2 pictures because they can't tell yet if she's going to name the tack or the tag. Then they hear the k and they start looking at the tack a whole lot. In contrast, when they're listening to this male speaker who has the accent, if they hear him start to say click on tack, they should know that he's not going to end up naming the tag because for him, tag has that a vowel. And so they should look a lot more at the tack than at the tag. So the accent should actually help them more quickly identify which picture is going to be named. And so here are our results. So again, these are trials where the correct picture was tack. On the x-axis, again, I'm showing you time in milliseconds. And on the y-axis, I'm showing you proportion of fixations to the pictures on the screen. The blue lines represent trials where the participants were listening to the male speaker who has the accent, and the red lines represent trials where they're listening to that female speaker who doesn't have the accent. And what we can see is participants are indeed looking at that target picture, the tack, more, and the competitor picture, the tag, less when they're listening to that male speaker who has the accent. So they are able to use information about how the speaker would have said that word tag to rule it out as a possible interpretation of what they're hearing. And so this shows us that listeners can quickly apply talker-specific knowledge just over the course of even hearing a single word, so that's pretty quick. But that doesn't answer the question yet of how listeners are able to adapt, and specifically, what are they storing in memory? How are they accessing this knowledge about the different talkers' accents? So there's one popular theory in speech perception that suggests that episodic memory is necessary. Episodic memory is a type of declarative memory for specific events. So think of telling a story or a memory that you have. So for example, I could tell you about the time I went to Italy, and I could tell you what I saw and what I ate and who I went with. That's the sort of thing that episodic memory entails. So according to this theory of speech perception, listeners store every instance of speech that they hear in this way. So for example, if I heard my friend Scott say tag, and he actually is the one who did the recordings for my experiments, I would not only store in memory the acoustic form of that word, but also who said it, where we were, maybe what we were talking about at the time. And then when I hear a new instance of speech, what this theory says I do is that I activate old instances of speech that I've stored in my memory that are similar and use that to help me interpret the speech that I'm currently hearing. However, these claims have never really been directly tested, and so that's what we're looking to do at Experiment 2 here. So we actually had the opportunity to test some amnesic participants. These are people with severe declarative memory impairments, so they cannot create new episodic memories. So under this episodic theory of speech perception, we would predict that amnesics should not be able to learn this new accent and use the information while they're listening to speech because they can't create episodic memories of the speaker's voice. However, if episodic memory isn't necessary, then they should perform very similar to the undergrad participants that I showed you in Experiment 1, as well as some age-matched comparisons who don't have any brain damage. So we have 4 patients with severe declarative memory impairments, and then 4 neurologically intact participants who are matched with the patients on things like age and sex, but they don't have any brain damage. So again, we predicted if episodic memory is necessary for learning and using information about different talkers, the amnesics should not show that benefit for listening to the speaker who has the accent. They should look exactly the same regardless of which speaker is talking. However, if episodic memory isn't necessary, we should see a pattern of results for our amnesic participants that looks a lot like what I showed you previously in Experiment 1. So first I'll show you the data from the comparison participants. So these are the people who don't have any brain damage. And this is just a nice sanity check. The effect from Experiment 1 replicates with this group of participants. They're looking at the tag more and the tag less when they're listening to the male talker than to the female talker who doesn't have the accent. So now I'll show you the data from our patients. And we do indeed see the same pattern here. And actually, when we compare the two groups statistically, there's no difference between the comparisons in the patients. So the magnitude of this accented talker benefit is similar across the two groups. So it looks like since the amnesics were able to use information about the different talkers' accents in time to help them process the speech, episodic memory is not the mechanism that's necessary for learning and applying talker-specific information during speech processing. And this is some of the first evidence, again, that directly counteracts those claims. And so this is an important first step for understanding how listeners are able to process speech of different talkers, how they're able to learn about different accents and different voices. However, obviously, we want to know now if it's not episodic memory, what is the mechanism, and we're still not quite there yet, but that's something that we're looking at in the future. But this is an important first step in understanding adaptation to talker variability during speech perception. And so I'd like to just thank my co-authors, Melissa Duff and Sarah Brown-Schmidt, our voices in the experiment, all of our awesome participants who do 1,000 trials of this, and of course our funding sources. Thank you for being such a great audience.
Any questions?
So you said that for Experiment 1, you have a period of time where people are exposed to the same talker talking about these specific words. I was wondering how important it was that Scott was talking about pigs and whether you get the same effect if he's just talking about babes and agriculture.
Right. So the question is then whether if they learn something about him saying all these egg words, if that would translate over to a new egg word that they've never heard before. This is something that we have thought a lot about. People ask us this a lot, and we have not come up with a good way to test that question with this paradigm. We use a lot of repetitions of the same word when we do this because we need a lot of trials to see the effect, and so there just aren't enough egg pairs to be able to test that, and so I can't speak directly to that. I can speak directly to the fact that they don't need that period of initial exposure we've run subsequent experiments using the same stimuli where they haven't heard the talkers at all until they actually get into the eye tracking task, and they can learn this information just over the course of the eye tracking task. But whether it would generalize to new words is still an open question.
Another question? Back.
Have you looked at, the pictures are in color, right?
Yes.
So does color play any role in what attracts someone's eyes first?
Right. So for example, if one picture was like way more exciting than another picture, something like that.
'Cause one was red.
Right. So we actually use a variety of stimuli. So we don't just have tack and tag. We also have back and bag and shack and shag. It's a shag carpet. And so if there were any differences, this is something that we would expect to kind of wash out over all the stimuli. We've never done any formal testing, looking at like the luminance or something across all the pictures, but we do have a variety of stimuli, and so hopefully we wouldn't get that effect. Yeah.
At 0 time, you start out with 25%.
Yeah, that's true as well. So before they've heard any of the speech and they have no idea what picture it's going to be, they do look at all the pictures about equally. And we do test to make sure that there aren't any baseline effects like that. Yeah.
Another question?
So I noticed that the unrelated images matched orthographic with wig and wig.
Yes.
Do they always match, and how do you choose the unrelated words versus the related words?
Right, so the unrelated words do all end in K and G the same way as the critical words do, and none of them contain those A and A vowels, so like wick and wig, dock and dog. So we wanted to make them, complementary in the same way that the target and the competitor are, and there are trials where one of those words is what the participants hear. But yeah, so that's how we chose them.
Okay, so without making the non-words in, so something that would match the
Yeah, exactly. So we wanted to make them just as plausible, kind of, keep the purpose of the experiment unknown to our subjects. So we wanted to make them all similar types of words, but not involve that critical vowel contrast.
We have time for one more question.
Yes.
Were any of your participants not native English speakers?
No, so we make sure that all of our participants are native English speakers. We also make sure that none of them have the dialect where they raise that A vowel to A, because we want to see how participants are learning a novel dialect. So that is something we control for, but non-native speakers' understanding of English is also something I'm very interested in too. But yeah, separate question.
Well, let's thank our speaker once again.
Thank you.